Okay, so I want to talk to you about some of the sample problems from your section 1.5. 1.5 is the applications of quadratic equations, so we should expect everything in this section to be about quadratic equations and some reading problems related to that. So there's some standard types that you will encounter in your homework. The first deals with a right triangle. Whenever you have a triangle with one right angle in it, it's true that side squared plus side squared will equal the hypotenuse squared. So again, opposite the right angle is always the hypotenuse. It needs to be on the alone on one side, the equal sign. So a squared plus b squared, and those can be in either order, but it does need to equal c squared, the hypotenuse. So we look at our choices here, which one matches up with that. We've got our x squared and our 3x minus 7 squared equals 4x plus 7 squared. Is that the only one that matches? Okay, so it was just the first one. So just find the form, and they're not asked to solve it just yet. We'll do that later, though. The second one is setting up an equation that would state what's going on in this picture. It says the mat and a frame around a picture shown measures x inches across. So we're talking about just the matting here. Which equation says that the picture itself is 700 square inches. All right, so the 40 inches is the outside measurement, which includes, they're calling the picture this inside. I don't know if you can see that really well. Some behind. Then there's a mat, right? What's x inches? You can see describes just the distance. And we don't know what it is. It's unknown x. And we don't know what anything measures right now except the outside dimensions. The question is, what is the area of the picture? So this inside dimension. So what we want to think is this outside dimension that includes the mat, the picture plus mat is 42. So we would need to take 42 inches, come in x this way and x this way. So it'd be 42 inches, subtract x to get to the picture itself is 42 minus 2x inches. And then for the width of the picture, we could do the same argument. The outer dimension, 21 inches, is too big. We're going to come in x inches in the mat this way and this way. So it's going to be 21 inches minus x, or minus 2x. So then the area of this rectangle, this length times width, will equal the area of the picture. It says 700 square inches. So we look for the equation that says that. Oh, I think it's A again. 42 minus 2x, that's the length, and then times the width, 21 minus 2x, length times width equals the stated area of the picture, only 700. So that's A again, and we're not asked to solve it again here. All right, third question, again, just practice setting up these equations without solving it. We encountered this guy a little later too. It's the box type of question. You've got a piece of metal, a flat piece of sheet metal, and then we cut out corners. We clip out the corners. In this case, we've clipped out 2-inch squares, the corners. Again, it was a piece of Plano sheet metal, or whatever material, but it's just a rectangle. And then we clip out the corners. When you clip off the corners, snip those 4 corners off those squares. And then if you fold up this side and you fold up this side, it makes a box, an open top box. And then it says the volume of the box is 76 cubic inches. So what you need to know here is the volume of a box is the length times the width times the height of the box. So this is it as a flat piece of metal, and it was x plus 9 inches this way, x this way, originally before we cut out our corners. We clip off our corners and get into a box. It's going to be minus 2 minus 2. So we're like above. We have 2 sides to consider. 2 inches this way, 2 inches this way would be minus 4 inches, making it x plus 5 for the actual length of the box. Then for the width of the box, this direction, the original rectangle was x. Then we take off 2 inches and 2 inches, so we take off 4 inches. And that's the width of the box, x minus 4. And then the height, how tall it stands, is that 2 inches you're going to flip up there. So the height is 2. So we can say the volume given is 76 cubic inches, and it's in cubic inches because it's three-dimensional, so it would be inch times inch times inch when we multiply the 3 dimensions. So cubic inches. The length is that x plus 5. The width is the x minus 4, and then the height is that 2. And then we look over here for the one that matches that. And so again, this is just a matching question. It looks like it's answer D on this one. Okay, and next we'll start solving some equations. Other backside to this. Oh no, next we have another practice setting up. Sorry about that. Still some practice setting up. So number 4. Same question, only this time it tells us the original piece of sheet metal is a rectangle, and it's 3 inches longer than wide, so that's where we get this x plus 3 and x. So just looking at it like that before we clip out the corners. Then we clip corners out, these little squares from the 4 corners, and in our example here, they're 1 inch. So we've got 1 inch squares all around, and then we fold the flaps upward to make it into this box, and it's an open top box, and the volume inside the box is 80 cubic inches. So again, we need that formula: length times width times height for volume of a box, rectangular box. So after we clip out our 1 and 1, this will be x minus 2 when it's in box shape. This direction, it was x plus 3 original. We clip out 1 minus 1 minus 2, make x plus 1. That's where they get that number. And then the height of the box is this 1 inch that's standing upward. So 1 or that. So the volume, and it gives that in the problem, is 80. So 80 equals, length is plus 1. The width is x minus 2, and the height is 1. We look for that equation in other order: x plus 1, x minus 2 times 1 equals 80. You know, with the equal sign, it can be written in either direction. It's a statement of equality, so you can flip around and it's the same. So notice D has done that. Okay, number 5. We're interpreting this equation, so go ahead and pause the video and read that equation and see if you can pick the answer. I'm going to go ahead and keep talking though. So suppose that the quadratic equation, and they have the equation already modeled for us. We do not have to find the equation, it's given. We just have to interpret what is x standing for, what is s standing for. And it tells us that this models the sales of new cars, where s represents the sales in millions. So this is the sales in millions of dollars. And then x equals 0 represents the year starting at 2000. So x equals 0 represents the year 2000. So x is 1 would be 2001, and so on. So if we put a 1 in for x, we're talking about 2001. So which equation should be used to determine the sales in the year 2010? So 2001 was 1, so 2010, 10 more years, looks like that would be at x equals 10. So it's telling us to change these x's, and there's x in 2 places in this quadratic equation. Make those x's into 10, so carefully look at your equation. Don't want to put in 2010, we just want to put in 10. It looks like this one, doesn't it? So here's the equation. Double check all the numbers are correct. That's a 10. They plugged in a 10 for that x and left everything else alone. So C would represent that. And if we wanted to know the sales in 2010, we would just plug those numbers into our calculator, and it should give us or model the sales. Okay, go ahead and read number 6. So this is our rectangle piece. So I've got a couple of those we're going to work, and we're going to actually work these all the way out from what we learned before. So we start with a rectangular piece of metal, and it gives us a clue about that rectangle. So we set up, it's 25 longer than wide. So I know nothing about the width, but I know the length is 25 longer than that. So that starts our visual. Then we're going to cut out the squares from all the corners. So clip out your corner, and they're 5 inches around. And then we form that box we've been talking about, and the volume of the box is 2,220 cubic inches. So what does our box look like? When we clip out 5 this way and 5 this way, it's like subtracting 10. So 10 subtracted from that will make x plus 15 for the length. For the width, we clipped out 5 this way and 5 this way, so we subtract 10. So the width will be x minus 10. And then the height, how tall the box is, if you think of it in, I'm not doing a great job there, 3-dimensional, the height of it is that 5 inches that we flip up. So it's 5 inches tall. And anyway, the 3 dimensions, we multiply those together, and that equals our volume, length times width times height. And it tells us in our problem what the volume is. So we have, I'm going to need another sheet of paper here. There's not room there to work that out. I see that. So we're going to need, the formula is volume equals length times width times height. So we've got 2,220 equals the length. And really you can put these in any order because we're multiplying the 3 dimensions there. Now, luckily on this problem, to help us reduce it some, we can divide out the 5. It will divide into this side, and why not do that? Just to make our problem a little easier. So divide each side by the 5 to reduce your equation, and because those are all multiplied, you can divide out a piece of that and simplify your equation. So let's see what the calculator says. I do not know that off the top of my head. 2,220 divided by 5 is 444. So that reduces my equation a little bit. Then to solve, now we've got this quadratic looking equation. I've got to, it's not in zero factor property form, because if you had something times something equals 0, that would be nice. That's zero factor property we learned in 1.4. But we cannot say here, calculate, put this in quadratic static form. We use the FOIL method. FOIL, your binomial times binomial. And then simplify it. Let's see, minus 10 and plus 15 is 5x. And then we can bring the 444 across the line to get it in standard form. So 0 equals, standard form for a quadratic. And let's see, what is that? That would be 594, I believe. And, I'm not overly familiar with the factors of 594. A lot of times these come out kind of ugly, big numbers that you might not be able just to work as easy off the top of your head. So use your calculator, or just use the quadratic formula if you don't want to mess with factoring. But I'm going to try some factors of 594. And let's see. I feel like maybe, let's divide it by 16. No, can you see that? It didn't really come out even for me. Let's see, can you see that? Okay, so let's try 594 divided by 20. I wonder if it divides by 20. No, it came out 29.7. 594 divided by 22. I'm just kind of guessing some middle numbers. That actually worked for me. It turns out 22 times 27 is 594, and when I subtract those, I will get the 5 in the middle. So it looks like that will factor. I've got an x times an x to get the x squared in the first. I need a positive 27 and a negative 22. Notice that last times last would be negative 594. The signs need to be different. Then the inner is 27x, and the outer is minus 22x, which gives me the right middle term, 5x. Now, if you just hate that, you can always use the quadratic formula to solve your quadratics. You do a is 1, b is 5, and c is negative 594. You plug it in your quadratic formula. That works as well. But most of these reading problems factorable. Just know you can do it that way more than likely. Once you get factors and then equal to 0, then you can set each factor equal to 0 to solve each part. So this will give us a negative 27 and a positive 22. And these are the solutions back over here. You remember way back when we were talking about the original rectangle. The original rectangle was x and x plus 25. Right? The length times the width. So x represents how wide is that original rectangle. We found x. It said x 20. So if the question is, what is the original width? That's our 22 inches. What is the original? Now that's not the 27 or any of the other numbers we found there. Remember, the length is this direction. The width is x, the length is x plus 25. So once we know the width is 22, 22 plus 25 is what we're looking for. 22 and 25 for 47. So that would be your final answers for that problem.